Okay, we're going. I really do think communism is a great idea, though. See? Yeah, but it doesn't work. It doesn't work. We're all a little bit too selfish. So this is the review of the review. It's the day before the test review, which is even reviewier than yesterday. I'm using that word. I'm going to get it into the lexicon. Here's a question. You have a sports car. Lauren's driving to work, school. And it is advertised to be able to stop in a distance of 50 meters from a speed of 90 kilometers per hour. Being able to stop faster is a good thing?
Yes.
Yes. Why?
So you can not crash.
So you can not crash and not hurt people and all that stuff. What do you think allows a car to stop faster? Thomas?
There's like some different materials.
Right, so you got the materials in the brakes that if you don't know a brake, when your tire spins, there's a metal disc attached to it. And Ashley's going like this.
Yeah, like brakes, they don't just like brake because if you brake super hard, you actually when you spin. But
Oh, you're talking about the ABS.
yeah, that's the
Yes, good. So when I was your age,
you have to manually.
okay, listen to this. You're gonna think this is funny. I grew up in a small town, and so so many stories to tell. I don't want to tell. I don't want to take too long. I'll tell you my first vehicle story later, but the first winter driving that I did, I was about 14, and my friend's dad said, "You boys need to learn how to drive on the ice," because in our town we had like 4 months of icy roads. And so he took us out in his old truck, and we drove onto a lake. So the lake in the middle of winter has 2 feet thick of ice, right? And the wind had blown the snow off this particular day. And so we just drove out there, and it was just like a big sheet of ice, and you could drive and just hit the brake and turn, and you would just go, and you just spin, and so you got really used to trying to drive without skidding, and you found as soon as you push the brake, your tire stops moving. What does that do? Then you're sliding. Okay. So the great thing about tires is that they flex, right? So if the tire flexes a little bit, it produces a force and will slow the car down. But once that goes, then you're just sliding. So we were taught to pump the brakes. You push the brake and let the tire roll, and so you get the flex, release, flex, release, flex, release. Now you have ABS brakes, automatic braking system. And it's just a big, we can go through how it works later. It's a big switch, and it goes, and it kind of hammers the brake, so it goes flex, release, flex, release, flex, release, and you slow down faster. Anyway, that's all. You don't need to know any of that. Sorry. Here's where the review starts. 50 meters from a speed, 90 kilometers an hour. What is its acceleration in meters per second? Wait. We're braking. How is this acceleration?
It's negative.
So we're moving forwards, accelerating backwards. Is this allowed?
Yes.
Does that make sense?
Yes.
Yeah. It's a change in velocity, but because we're going from a high velocity to a low velocity, it's a negative acceleration, a backwards acceleration. Okay. And then we say, how many G's is this? It's a shame Kai's not here because he would understand this. But wait, can someone tell me what a G is? Declan.
Actually, I don't know.
Take a guess. He threw his hand up.
The title of that one hamster movie, you know, that's what
It's not. In this case, it's not a title of a hamster movie. Taylor, what's a G?
Isn't it the amount of, it's the amount of pressure from, I don't.
You're on the cusp of it.
know it might have something to do with gravity.
Yes, it does have to do with gravity. Very good. Yasmin.
The force of gravity.
Okay, the force of gravity. So right now, how many G's are you experiencing?
One.
1 G. So the force of gravity on you is 1 G. If I drop this, it accelerates at 9.8, right? Force of gravity is 1 G. So when you hit the brakes, what happens? If I'm in the car and I hit the brakes, what do?
Your body goes forward.
You feel like you go forward, right?
Yes.
What's actually happening?
Because
You're still going forward.
You're just going forward the same velocity, and the car is
Going down.
slowing you down. So your acceleration is backwards, right? Okay. Who did it? Yazzie, talk to me.
First I wrote down everything we know.
Oh yeah, what do we know? Tell me.
The distance is 50 meters. Our VI is 90 kilometers per hour, which is 25 meters per second.
So you divide by 3.6
Yeah,
and equals
25.
25 meters per second. Good.
And our VF is 0, so the time would stop.
Very good.
And we want to count the A.
Good. Want to find the A. So put your hand up. Thank you very much. Put your hand up if you can tell me what formula we would use. Ashley.
VF squared equals VI squared plus 2AB.
Good. And Amir, what are we solving for? Solving for A. Who can tell me what the manipulated formula will be?
Vx minus Vi plus T divided by 2.
VF squared minus VI squared over area? Good. Over 2D. So you subtract this over here, and you divide the 2 and the D over here, and that will equal A. If you plug that into your calculator, I haven't done this, but this is going to be 0, right?
Yeah.
And this is 25. 25 squared is 625?
Yeah.
So negative 625 over 2 times over 100, so that would be negative 6.25. Negative 25. What's my units here?
Meters per second squared.
Meters per second
Squared per second.
squared. This negative, is that a value or a direction? This is a direction. That just means we're accelerating in the opposite direction of the way we're moving. How many G's? How would you find out how many G's?
Divide by 9.
Good. Good. Matthew, very good. So if you divide by 9.8, you get what? 0.8 or something? 0.63? I guess that makes sense. 0.63 G's.
Shouldn't it be negative?
Yeah, I guess you could, well, okay, so here's where the negative thing falls apart a little bit, because this negative means backwards. When we do negative 9.8, what does that mean? It means down. So you have backwards and down. They're not really the same positive, negative, opposite thing, right?
So here's the final answer.
So you could put negative, and you could have positive, or you could have positive, and you could say negative, but it doesn't really mean negative. It just means that's how much of a G you are experiencing. Because those directions don't jive. Okay? The math doesn't always fit the real world. How many people got that? Good. Excellent. Number 25. Try it. I wonder if this is clear on the thing. Should I read it to you? It says a car traveling 45 kilometers an hour slows down at a constant 0.5 meters per second squared. 0.5 meters per second squared. Just by letting up on the gas. So we're not braking, we're just releasing the gas pedal. If we're not releasing the gas pedal, then why are we slowing down?
Friction.
Just friction. Sorry, I said that wrong. If we're not braking, why are we slowing down? Because of friction. Correct. Actually, good. So we're just coasting. Okay, we release the gas, no brake, no gas, no force in either direction. Or is there a force?
There it is.
Is there a, we're moving forward. Does that mean there's a force forward? Nope. Nope. No force forward because the engine's not doing anything. So which direction is the force? What's acting on the car? You just told me. Friction. So friction is backwards. It's only one force. Only one force. That's important for later, not for this stuff. Okay. Calculate A, the distance the car coasts before it stops.
Genuinely don't know this. So find VF.
Maybe we should just do that first. You want to do it together? Do you want me to give you a minute or two to work on it? Okay, try it. Try it. So do the distance the car coasts before it stops. And then the time it takes to stop. And C, the distance it travels during the first and 5th seconds. This is interesting. Someone stole my calculator. Hey, look at this. I never ate it. I went the whole time putting it back here. Lilia, how would I convert kilometers per hour to meters per second? Very good. Divide by 3.6 and I'm gonna get
Till it stops.
12.5
Before it stops.
meters per second.
You dared to.
Jimmy, why do I make the acceleration negative? Good. It's accelerating backwards, slowing down. Azia, what's my VF?
0.
Good.
Someone said to start with Ocean 11 Yeah. And then I heard that, I was like, okay, I actually have to invest some time and read it.
Hey, I got a question for you.
Yeah?
if this is minus 12.5, does the square affect the negative?
No.
Not in this case. If it was negative 12.5 meters per second, then the square would have to turn that positive. But because this minus is outside of the square, exponents are extremely lazy. Even lazier than physicists. They'll only apply to the first thing in front of them. They count. Over 2 times negative 12 and a half squared. Oh, that's like 144.25, right?
Oh, yeah.
144 meters? Is that right? Did I do that right? No?
It's supposed to be, yeah, 0.25.
0.25. Well,
156. 156.
156?
Yeah. Okay, 12.5 times. 12.5 squared is
Yeah.
156.25.
Really?
Yes.
You only did.
You only did 12 squared.
Yeah, I know. But then,
That's supposed to be, when you square it.
okay. 156.
156.25.
That surprises me for some reason.
Here, I shall type all of it out, so I'll go
Yeah,
No, that-
2.5 times.
56.25.
Yep.
Okay. My mental math is off there. 156.
What was the last question?
0.25.
0.25.
We'll just round it. And this is meters, right?
Yes.
So that's the meters. The second thing was the time, right?
Yeah, and what was the last one?
The last one was how far does it travel in the first second and the fifth second. So let's do the time first.
How far did it travel in the first second and the
So this is 25
Yeah.
seconds.
Yeah.
So the whole trip is 25 seconds. The last one is interesting. For C, it says how far does it go in the first second? So you have to do the displacement at t equals 1, right? So you say if t equals 1 second, what is the displacement? So we can probably use this formula. So this is going to be 12.5. Oh, do you want time to do this?
Yes, please.
Sorry. Sorry.
Is it after the first second or just in the first second?
So during the first second
Oh, okay.
is from t equals 0 to t equals 1. So because at t equals 0, we know it's at 0. You just have to find t equals 1. So this is the first second.
Why did T equal 1?
if you've got the answer for the first second. Harriet, tell me how you did it.
For C, first I got the time for first second, and then for the fourth, T equals 4.
What do I know? I just mean the first second. How did you do this part?
I did that and I did 12.5 minus 3.25.
So just 12.25? How many people got that? Good. So this, it kind of makes sense if you think about it. We're not accelerating very much, right? We're not slowing down very quickly. It's only 0.5 meter per second per second. So at the end of the first second, how fast will the car be going? That's a question you should all know.
12.5.
Say that again.
12.5 meters per second.
Okay, so we start going at 12.5, and we're getting 0.5 less every second. So if at t equals 0, we're going 12.5, then at t equals 1, what will we be traveling then?
You take 0.5 off.
Yeah, so what will it be?
But it's 12.25 right now.
No.
That's the distance.
At the beginning, that's the distance. So we start during the first second. You start going 12.5 meters per second. You finish going 12. So kind of makes sense. You go 12.25 meters, right? It's right in the middle.
6.5 off each second.
Okay. Who's got an answer for the 5th second? Who needs another bit of time? Okay. I'll let you go.
For that much.
Wait a minute. 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, right? So your 5th second is from t equals 4 to t equals 5.
To find the
Yes.
5th second,
Yes.
what are the VI and 10?
We don't know what our VI would be. You have to find the V at 4 seconds, I guess. Well, we could work that out, right? It'd be pretty easy. Let's just do a little chart. Or we could just multiply. So if you have time here and velocity, at 0, you're going 12.5. At 1 second, how fast were we going? What's 0.5 less than this? No? The velocity, not the distance traveled. So at 2 seconds, how fast are we going?
11.5.
Good.
And you keep taking 0.5 off.
7.5, 3, and then?
11.
Good. 4?
10.5.
10.5, Matthew's got it. And at 5 seconds, we're going
So
10,
the
right?
velocity with the V, like the, oh, yeah. The VI for 5 seconds would be 10.
Yep.
Yeah.
So for this, if you want to find the distance in the 5th second, your VI would be 10.5.
Right.
Because you're starting at 4 seconds and going to 5 seconds. Now, if you wanted to find this out, you don't have to do this chart. You can say, well, 4 seconds later, if you do 4 times 0.5, that's 2. 12.5 minus 2, 10.5. Because it's weird to think about because the displacement is not changing linearly. the velocity is changing linearly. It just comes down 0.5 every single time. It's kind of weird, but it's simple. Which T do you use?
Trust Canada?
If you're trying to find the distance traveled in the 5th second, how much time elapses? 1 second. Easy and very good. You're just using 1 second, right? We're just changing our initial velocity. That's all we're doing. Our acceleration is still negative 0.5, and our time is still 1. So this is going to be 0.25 again. So the distance in the 5th second is going to be 10.25. Does that make sense? You can do that with formulas, but you can also, I want to kind of try to show you this a little bit. Let me ask you this. If this is the first second, from 0 to 1, that's the first second. What's the average velocity between 12.5 and 12? 12.25. That's the distance we travel between these two times. What's the average velocity between 10.5 and 10? 10.25. That's the distance we travel in that 1 second. So if I asked you to find the distance traveled between 3 and 5, what would you say?
It would be the average velocity.
What's your average velocity between 11 and 10?
When you add them together, negative 10.5.
The average is 10.5. Do you understand? It's right in the middle, right? But you're traveling that for 2 seconds, so how far do you go?
20.1.
So this, from here to here, is 10.75, right? From here to here would be 10.25. And all of this together, what did you say, Ash? 21. This plus this is 21, right?
What is that though?
This is the distance that you would travel from 3 seconds to 5 seconds. So
from the what is the average velocity between 3 seconds and 4 seconds? So 10 plus 11 plus 10.5 divided by 2 would be 10.75, and then the 10.25 is the average velocity from 4 to 5 seconds. And then you add those together, and that's the average distance for 3 to 5 seconds.
I'm hoping that got on the video. So what I'm trying to show you is that if you have a constant acceleration, your velocities change in a very regular way, right? It's consistent. It goes down by 0.5 every second. And that means that the average velocity is just the midpoint between any two of these velocities. And of course your distance is just that average velocity multiplied by the time. If I gave you those two problems, could you solve them?
Perhaps.
Yeah, let's say. Who feels good about those two?
I think I would have eventually.
Who
gone
feels
there.
like, yeah, I'm getting up to the edge of that's what I can do there?
No.
Okay, this is like 60% of them didn't say anything, so. I don't know where you're at. I gotta move this back here. Okay. One more.
Average velocity between 3 seconds and 4 seconds. Take the velocity, average velocity.
I think he's tired.
Plus this velocity divided by 2, so 11 plus 10.5 divided by 2.
You can always go back and watch the movies, right?
That would equal.
Hopefully, if it works.
10.7.
Okay. If you're good and you just want to study for the test and just do the normal stuff, carry on. If you want a little bit of extra, this is for you. This would be kind of more of a bonus type question. Let me see if I can get it lined up here. Number 28. Go ahead and try it if you like. If you're good, then you can go on and do the work on the textbook stuff, the reviews, whatever, any of that stuff. You just have time. If you want a little stretcher, this would be kind of something I might make as a bonus question.
Do you just like make up an equation?
Well, you don't make it up, but you derive it from the equations you know. Oh yeah, by the way, V0, this book goes by the English, like British convention. So V0 is like VI for us. And TR is just the time here.
The reaction time.
V0 is the initial speed of the car, TR is the driver's reaction time. Do you guys understand what reaction time is? So if you're driving along and a kid runs out on the road, you have to react, right? So there's a certain amount of time it takes you just to get your shoe onto the brake pedal and push it down. That's your reaction time. So what's happening to the car while you are reacting? It just keeps going the same velocity. And then once you apply the brakes, now we're accelerating backwards, right? So it's two different things happening in succession. I'm going to stop the video there. I'll put up a solution for this later. But you don't have to do that if you're just cruising for the test tomorrow.